Hundreds of miles above us, a fleet of NASA spacecraft constantly scans the Earth. One of these has dramatically improved our ability to study severe weather. TRMM, the Tropical Rainfall Measuring Mission, observes weather systems with the world's only space-based precipitation radar. TRMM peers down through clouds, revealing their internal structure. Using TRMM measurements, scientists identified a dramatic feature in the structure of Hurricane Bonnie. Towering rain clouds close to the eye wall nearly reached the stratosphere. These structures, called hot towers, extended higher than commercial jets fly. Research into these observations has led scientists to new insights about hurricanes. Let's look at the role hot towers play in hurricanes. A hurricane's eye is an intense low-pressure system. Near the ocean surface, air spirals inward in an attempt to fill the low-pressure region. As air nears the eye, it rises rapidly until forced outward at the barrier formed by the warm tropopause. The net effect is a cycle of air moving inward near the ocean surface, upward at the eye wall, and outward at high altitudes. The air picks up energy from warm ocean water through evaporation. This warm, moist air rises in the eye wall and releases its energy through condensation, sustaining the hurricane. Hot towers act like express elevators, accelerating the movement of energy into high-altitude clouds. This energy boost tends to strengthen the hurricane. What causes these hot towers to form? There's a big difference in wind speeds between the fierce eye wall and the relatively calm winds inside the eye. These rapid changes in wind speeds cause instabilities that can spin up intense vortices just inside the eye wall. Near the surface, air spiraling inward collides with these vortices, forcing the air upwards, creating an updraft. A very strong updraft in the eye wall carries moisture much higher than normal, creating a hot tower. High-resolution computer simulations of hurricanes show the formation of hot towers. In this simulation of Hurricane Bonnie, hot towers are clearly visible. The arrows show winds swirling near the surface where energy is picked up from the warm ocean. Some of this air moves into the hot tower and rises rapidly, boosting the hurricane's strength. But it's more complicated than that, because hot towers move with the hurricane, and there are often multiple updrafts. When air passes into a hot tower, it rapidly rises higher. Conditions are more favorable for vortices to form updrafts on one side of the hurricane, because wind shear amplifies colliding winds in that area. Wind shear causes these updrafts to weaken in other areas of the eye. Vortices can also pump high-energy air from the eye into the eye wall, boosting the strength of the updrafts and intensifying the hurricane. Scientists have confirmed a connection between hot towers and hurricane intensification. But forecasting intensification remains a difficult problem. Combining satellite observations with supercomputer simulations provides a powerful tool for studying Earth's complex systems.